Hi guys, and welcome back to the OQLIS YouTube channel. Today we will be looking at a more exotic chart that can be made in OQLIS, and this chart is called a choropleth. So what is it? Simply put, a choropleth is a map with predefined areas which are colored in proportion to a statistical variable. If that sounds like jargon to you, then here's a picture to clear a few things up. So why would you want to use a chart like this? Well, choropleths are perfect for displaying differences in locational data. That being said, you are not limited to geographical maps. Choropleths can be applied to floor plans, cross-sectional diagrams, or even a human body. However, there are some specific requirements that must be in place to get the most out of your choropleth. So let's begin with the data requirements. The most important thing is that you need to have categories for your data to be grouped by. For this example, I will be using a typical apartment. Now, take note that our rooms are categorized as shown. The next requirement is that you have some sort of numerical value that will determine the color or intensity of each category. I have got hours, which corresponds to hours spent in each room. So now that the data requirements are met, we will need to address some other requirements, namely the map and the color gradient. So if you head over to settings and click on maps, I'll show you how to do that. The maps used by Choropleth are typically created in Geojson. So if you're experienced and really know what you're doing, then you can code the Geojson from scratch in this window here. Otherwise, I strongly recommend heading over to geojson.io to draw your map instead. So I'm going to head over to geojson.io, and when the page loads for the first time, it will show a world map like so. The reason for this is that Geojson uses real longitude and latitude values to create maps like floor plans. So the map being shown is actually irrelevant, as we are just using the underlying coordinate system. If this is confusing you, let me show you what I mean. If I were to plot a random square on the map like so, let's say our floor plan was just a single room, that was a square, then the coordinates of this room or floor plan are plotted on the earth as real coordinates. Now the problem with this is that the square or the floor plan may be a little curved, especially if you're very far zoomed out like this. So to get around this, I usually zoom in quite a bit, like so. And it doesn't matter where you zoom into, since we're just using the coordinates and not the location itself. So here's your scale. I would probably zoom in until you start seeing meters, maybe 100 meters, like that. Now we can actually start with our floor plan. So you're going to need a URL of sorts. I've stored my floor plan image in a DigitalOcean folder. So if we navigate to Meta and click Add Map Layer, and then I'm going to paste my link to the DigitalOcean folder here, and now name it. Now this will show our floor plan overlaid on the map of the world. So now you're going to want to select either polygon or square to draw the sections over each room. I'm going to use square since this floor plan is basically all squares, but you should probably use polygons if your shapes are not square or rectangles. So you're going to just basically plot a square over every room like this, and then give it a name. And now it's important to remember that this name must correspond to the name in your data set. So, or in my case, it's the categories of my data set. And remember, it's also case sensitive, so this needs to be exact. Once you have finished plotting all your shapes and naming them, let me just name this last one. And also, once again, remember that these need to be in the correct case and spelled correctly. Then you can go and copy your your GeoJSON that's been generated on the side here. It should be quite long, depending on how many shapes you have. So I'm just going to select all and copy that. And then we can head back to OQLIS. I'm going to call this map apartment, like so, and then I'm going to paste that GeoJSON data here. And then we can hit save. Now our map is saved, and we can start building our Choropleth. Now we have our map showing here. If we click on it, it should load. The next thing you're going to want to do once you've created your map is create a color gradient for your map. So we'll do that by going over to themes and then clicking add new. We'll call this apartment. And now all you're going to do is select colors, but make sure to start at a light color and then progressively get darker and darker for each basically grade of color. And these will be the colors that your Choropleth uses. And that should be good to go. The next step from here will be creating your actual your Choropleth in the Explore tab. Okay, so once you have navigated to the Explore tab, we can begin building our Choropleth. I'm going to select my Choropleth data model, which we created earlier, and then I will move hours to the measure column and room to the hours to the measure box and room to the group box. So by default, this is going to create a bar chart, and these values are correct, but obviously we want a Choropleth, not a bar chart. So you'll select Google Maps and then go to the settings, and we'll change map provider to leaflet and map type to Choropleth. Then in your Choropleth map drop down, make sure to select the correct GeoJSON map. I called mine apartment, so that's already selected. And then color palette, also select the correct color palette. Mine is also apartment here, so both of these are correct. Then color group buckets. So this is how many different colors you want in your map. I only selected 6 colors in my palette, so I'm going to select 6 for the number of buckets. And now you can see we have 6, but our values are a bit funny here. So what we need to do now is go to the min and max value. Now the minimum time spent in any of the rooms was 0, so we'll leave this as 0, but the maximum amount of time spent in any room was 12. So I'm going to change that to 12, and you can see that now we have much better numbers on our legend over here. Okay, so the next thing we want to do is put in a background image. So this background image will be the same link that you used on geojson.io to make your floor plan layer. And I'm going to paste that in now. And there we go, there's our image. However, it's a bit big, and the Choropleth is tiny in comparison to this, which is why we can't see the Choropleth. So I'm going to go to background image bounds and change the size. A good idea here would be to look at the coordinates that your chart is using. Roughly it's about 2 and 0.5, so I'm going to use 2 and 0 for my Choropleth, just to scale it down a little bit. We'll do that like so. And you can see now it's tiny, but the Choropleth is also there. It's also tiny. So we're going to just zoom in a bit so that it's not that small. And now this will be the default size of our chart. And let's just center it by changing the center latitude. These you'll have to play around with just to find something that works, as all choropleths are different, so it can be different every time. Let's maybe change this to 1. Okay, so now it's still too big, so we're going to make it even smaller. Let's try 0.4 and 0.5. So now the difference between these two values here, 0.4 and 0.5, will be the height of the image, and the difference between these two values will be the width of the image. So let's make this 2.1 and 2.2. So now you can see our images while Choropleth is starting to take shape, but you're going to have to fiddle with these numbers a bit, because like I said before, every Choropleth is different, and so the background image bounds will be different each time, the zoom will be different each time, and your center latitude and center longitude will be different each time. But if you are struggling with this, just be sure to give us a call and we should be able to help. So after repeating this process a few times, these are the final values that I found work for my Choropleth. So as you can see, my image bounds are around 0.5 and 2, as I said earlier. My zoom is 12 and my center latitude is 2.06, center longitude is 0.48. And now you can see it's created a nice Choropleth with the image correctly scaled and positioned exactly behind it, and our chart is now complete. So we can save this chart by going up here and name it whatever we want, and then obviously click save. And then we can use this chart on our dashboards. If you enjoyed this video, please like and subscribe, and thank you for watching.